topic that I want to talk about now is electronic configuration. Electronic configuration. This electronic configuration is divided into two, which are what? KLMN and Spdf. For the KLMN, don't forget that from the atomic structure, we explain that this case represents shell. We call it shell. Shell. 1, 2, 3, 4. This one is what? K shell, L shell, M shell, and what? L shell. The maximum electron each can acquire for the K shell now. K shell can require a maximum electron of what? 2. L is what? 8. M is 8. N is also 2. If this K filled with 2 electrons and we have an electron remain to fill, we have to fill it what? We have to bring it to fill the L shell. Now, for instance, now join me. If we are given something like oxygen, atomic number of oxygen is what? Is 8. And the question asks to write the electronic configuration of 8. To write the electronic configuration for what? For oxygen. The first one will be what? The first shell will be what? 2. You know, the second shell is what? Is 8. But the remaining number, when we remove these 2 from 8, what is the remaining electron? The remaining electron is what? Is 6. Is that clear? Now, the same thing applicable to aluminium. Atomic number of aluminium is what? Is 13. Then it means that the first one we acquire how many electron? 2 electron, followed by what? 8, making what? Making 10. Still remain, Abi, 3. Let's look at another one, potassium, which is 19. The first one will be 2, 8, 8, 1. That is how that you are going to write the electronic configuration for any element that you are be given. Now, let's now move to what? Spdf. Let's talk about Spdf. Know that S means S block, P block, P block, D block, F block. Then for the Spdf, the first one is what? 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, right? 5d, 5f, 6s, 6p, 6d, 7s, 7 what? 7p. Now, followed by March, 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 March. This, okay, it is what? 7 what? 7s, 7p. Now, if you want to write this down now, first one is what? 1s, followed by what? 2s, followed by what? 2p, 3 what? 3s from the back, 1s from the back, 2s, 2p, 3s, followed by what? 3p, 4s from the back, 3d, 4p, 3d, 4p, 3d, 4p, 5s. Follow like that. That is how that we are going to write it. Now, let's now assume that the questioner has to write the electronic configuration of what? Of any element. Let's assume that we are be given what? We are be given sodium. Which atomic number is what? Is 11. We now ask that we should write the electronic configuration of sodium. Then, mind you, whenever we have S block, the maximum number of electrons they can acquire is what? Is 2. Whenever. If the electron you have is 3, it means that you cannot have 3 on what? On S. We can only have 2 on what? On S. Then if it is P, this one, 2, P can require maximum of what? 6 electrons. Why this what? 10, why F is what? Is 14. Is that okay? Now, let's now move. For the sodium now, if you want to write for the sodium now, we have one what? 1s2, right? We still have another S. Our acceptance require how many? 2. 1s2, 2s2, 2p what? P require how many? 6. Still give me 2 plus 2, 4 plus 6, 10. Then out of what? 11. What is going to be 1s, 2s, 2p, 3 what? 3s. The question cannot ask you that what block does this element belong to? Then it belongs to what? It belongs to S block. How do we know? How do we know that it belongs to S block? We know that one through what? Through what is N, the electron configuration. What is N there is what is S. Is that taken? Is that clear? Aha. Then you can be given in a question. You know, don't forget that when I was talking about ions, I said ions is divided into 2, negative or positive. In most cases, you can be given something like this, where you can be given something like this, N what? Na plus. They will not ask you that you should write the electronic configuration for this. You know, if you want to write electronic configuration for this, mind you, this element has lost how many electrons? 1 electron. If you subtract that 1 electron from the atomic number, it's going to be what? It's going to be 10. It means if you want to write the electronic configuration for this now, it will be what? 1s2, 2s2, 2p6. If the question now say this element is belong to what block? This now belongs to what block? P block. Is that okay? Don't forget. That's about that. Then what else again? Now let's look at one more example. Okay, phosphorus. Atomic number of phosphorus is what? Is 15. Are you getting me? There we are. Let's now write electronic configuration for the phosphorus. 1s2, 2s2, 2p6, make it 10, right? What is follow? 1s, 2s, 2p, 3s, 3s2, making how many? 2 plus 2, 4, plus 6, 10, plus 2, 12. Give me what? Give me 3. 3p, right? Then 3p can require maximum of what? 6 electrons. Then what is left now? 3. If you count everything together, 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 3, 15. You can come across of something like this in your JAMB exam, where they will ask you that this electronic configuration, it represents what element? Now, this one is represent what? It represents phosphorus. Because atomic number of phosphorus is what? Is 15. Then if you count the number we have here, it's also what? It's also 15. Now, another question. Let's look at another question. If you have been given a question like this, then they ask you to write the electronic configuration for this. Mind you, this element has gained 2 electrons. The atomic number of oxygen is 8. Then when it has gained 2 electrons, you now add 2 plus that, making what? Making 10. If you want to write electronic configuration for this, hey, wait. Let me start from oxygen. Oxygen atom. Oxygen atom is what? Atomic number is what? Is 8. 1s2, 2s2, 2p what? 2p4. This is what? Electronic configuration of what? Of oxygen. If the question asks you that what block does this element belong to? It belongs to what block? P block. Is that the king? Now, let's now talk about this one now. Yeah, oxygen has gained how many electrons? 2 plus 8, making 10. It means that the atomic number of oxygen now is what? Is 10. Is that the case? If you want to write the electronic configuration for it now, it will be 1s2, 2s2, 2p what? 2p6. This one also is also belong to what block? P what? P block. Is that taken? Let me give you one more example. Aluminium 3 plus. Hey, let's write electronic configuration for aluminium atom first. Aluminium atom, atomic number is what? Is 13. 1s2, 2s2, 2p6, 3s what? 3s2, 2p what? 2p1. Hey, no. 1s2, 2s2, 2p6, 3s what? 3s, then it is 3p. 3p. Now, 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 1, 13. That is what? This electronic configuration, it represents aluminium, it represents elements, which is what? Which is aluminium. Then, the question can also ask you that what block does this belong to? It belongs to P block. If you have been given aluminium ions, and the question asks to write for the electronic configuration of the aluminium ion. To write the electronic configuration for the aluminium ion, it will be what? Don't forget that this 3 plus here means that this element loses how many electrons? 3 electrons. If we deduct 3, if we subtract 3 from 13, making what is remain 10. The electronic configuration now will become 1s2, 2s2, 2p6. 2 plus 2, 4 plus 6, 10. Then the question can also ask you that what block does this belong to? It belongs to what? It belongs to P block. That about the what? About the electronic configuration. The next topic that I'm going to talk to is what? Ground state. Join me.